Welcome, everyone, to this evening's 7 for 7 YouTube live event. We're really excited to have another opportunity to do a replay of a 7 for 7. My name is Kevin Spry. I work as the Professional Development Manager for Texas Instruments in the Education Technology Division. The 7 for 7 is the session that we host at our annual T Cubed International Conference. It's an opportunity where 7 educators get to talk about something they are passionate about in education for 7 minutes. Hence the title, 7 for 7. And we're really happy tonight to have one of our speakers from past conference, and that's Pam Harris. Hi, Pam.
Hello,
Good to see
Kevin.
you.
Thank you.
Hi. You're welcome. Pam is, I think many of you probably already do know her, but in case you don't, she's has a history of she's a former secondary math teacher. She's currently teaching at Texas State University and is a K to 12 math education consultant. She's a T Cubed national instructor. She's an author, facilitator of several professional development workshops, and she's the founder of mathisfigureoutable.com and Mathisfigureoutable podcast. I love that, and I actually love the whole site. It's great. She's the author of numerous books, including the new algebra problem strings and advanced algebra problem strings. And those are great. I've certainly seen Pam discuss those. She's also involved with the textbook Discovering Advanced Algebra and Building Powerful Numeracy series from the Powerful Numeracy for middle and high school students, lessons and activities for building powerful numeracy, and building powerful numeracy, a facilitator's guide. So Pam, as you imagine, is very busy. She frequently presents at national and regional conferences. In fact, this morning she was part of NCTM and their virtual conference. Her particular interests, obviously involving, as you can guess from some of the titles, numeracy, sequencing of rich tasks, and teaching with technology and assessment. And she's also been involved with vertical connectivity and curricula for schools from K to 12. So we're kind of excited to have this. We had an opportunity to hear Pam live. I believe this is at the Baltimore International Conference, but we're going to see or do a replay of this session on perspectives impacting pedagogy. And then you'll have an opportunity to have a chance to ask questions of Pam. We'll have a chat with her about her session and get to learn a little bit more. So with that, we'll start the video.
And I wonder if we could consider that the perspectives we have impact the way we teach, that maybe then we can choose the way they impact the way that we interact with our students in classrooms. So I'd like to show you, a couple of images. You might see 3 images up here if you look in the white spaces. Do you see some animals? Do you see like a dog maybe and a rabbit and a cat? But now I'm going to invite you to look at the lower left-hand corner. Do you see a baby? And now that you see a baby, do you see people? Yeah, now that you see the people sort of in the dark, shadowy spaces, do you have a choice? Now you can either choose to see the people in the dark, shadowy spaces, or you can choose to see the animals in the white space, and I have just affected your perspective. And what I'm going to suggest is that if we can admit or sort of acknowledge our perspectives, then we can choose the way they impact how we let them impact how we teach mathematics. So I'm going to introduce 3 perspectives that I think are alive and well in the United States today that impact the way that we teach, and I wonder if I could hear from you which way you might identify with. So here's the first one. Anybody recognize the movie? So this was Hidden Figures. No spoiler alert, I'm not going to tell you too much about it, except these 3 women, this could be a typical equity talk, but it's not. These 3 women worked for NASA as mathematicians in the late 50s and early 60s when we were trying our hardest to get people into space. Well, actually, we could get them into space, but we couldn't get them home, and that sort of mattered to the astronauts a little bit. And so the movie's all about these mathematicians working to figure out new science in order for us to be able to get those astronauts home. If these 3 women worked as mathematicians for NASA in the late 50s and early 60s, I'm going to suggest that they kind of did it on their own. In other words, when their math teachers presented math as a series of procedures and facts to memorize, I think that somehow these guys saw behind it. Somehow they saw through those rote procedures and things to memorize, and they sort of did real math. They created relationships and connections in their head that they were able to solve problems with. In other words, when their math teacher said something like, what is 99 plus 47? Ooh, don't think about 99 and 47. Let's line those up, and let's only think about digits here. Only pause and think about right now about the 9 and the 7. Don't think about 99 and 47. Add those together. And they taught those kids the traditional algorithm for addition. I would suggest that these guys somehow saw through that. And they said, I mean, you could use the algorithm to add 99 and 47, but nobody is, right? I mean, you're just all thinking about 99, 100, and then what's left over, 46? So you're just thinking about 146, and then you assumed the rest of us were too. If you identify with that perspective, then I'm here to tell you the rest of us did not. The rest of us actually dutifully just did what our teacher told us to do. We lined those numbers up and thought that was the meaning of addition. We followed the rules and spit out a bunch of memorized stuff and thought we were doing mathematics. So somehow, I don't know how, I'm going to back this up because I can. They made me time it, and then they told me I didn't have to, so I'm going to take my time and talk a little slower than I was going to. When you somehow saw behind those procedures and then say to yourself, I'm going to teach the way I was taught because it worked for me, and I guess if it doesn't work for the rest of you, you just don't have a math gene. Not true. The rest of us can mathematize just as much as you do. We just might need to see your brain on paper. We need you to use technology and the power of visualization to help us make the same connections you made. And then we can absolutely mathematize right along with you. I'd like to introduce you to a second perspective. This is the movie Stand and Deliver. It's a little bit older. This is about Jaime Escalante. It's a little dark, sorry. The guy on the left is a teacher who actually started out as an engineer by trade. And he decided to give back to the community. And so when he retired, he went to a rough part of East LA, grabbed a bunch of kids by their bootstraps, and pulled them up through calculus. It's a great story. Highly recommend it. I'm going to poke on a little moment in the movie for a second. In the movie, the kid on the left had just flipped him off. Brand new teacher, he's got a decision to make, just got flipped off. What are you going to do? He gets right in that kid's face and he says, oh, you're the finger man? Let me tell you what I can do with my fingers. And he proceeds to teach the kids the 9 multiplication trick, as if multiplication by 9 is a trick to memorize, a procedure to just mimic, not real mathematics. I would suggest that this is the perspective I identified with, that I identified with fake math. That math is a set of things to memorize and rules and procedures to mimic. Not so. That isn't real mathematics. I'm a little bitter today because I actually could have understood all that stuff I wrote memorized. When he presents the 9 multiplication trick, it's only for single-digit facts. Okay, it doesn't help me with any other 9 fact, but if he could have instead said to those kids, hey, you can think about 9 times anything as 10 times anything, and then just get rid of one of those things. Well, now that doesn't just work for single-digit 9s. I can do that for any 9 fact. That's real math. If you identify with this perspective, if you dutifully just said, yes, I will follow your instructions. I can control this. I will follow your instructions, and I'm just going to go ahead and dutifully memorize those isolated facts and regurgitate or mimic those procedures that you've given me. If that's the perspective you identified with, may I invite you to real math? May I suggest that there are some things we can do to actually mathematize our world? I have some suggestions at the end of the slide. Show if you identify with this perspective, I invite you to begin to mathematize with the rest of us. How did I begin to mathematize? Because the first 3 kids God gave me came out of the womb mathematizing. I'm not quite sure what I give them credit, but they dragged me out of that rote memorizing procedure land into a mathematizing land. And I'm so grateful for that because then I got her. So this is my 4th. You don't recognize her because it's my daughter, but literally my 4th kid came out of the womb asking, why? And somehow this represents to me a perspective that's alive and well in the United States. It's a group of people who cannot do it unless they understand why. You might know this kid. This is the kid that when you say, okay, look, I've explained it 3 times, pick up your pencil. And the kid finally picks up their pencil and goes, but, and you're like, seriously, write down the first thing. Like, I've explained it. Do you know that kid? The kid that goes, but, and then they sort of have to sell their soul just a little bit in order to just do your rote memorized procedures because they really don't want to do that. They know they have this sort of sixth sense that they could understand why. These are the students that always go, why? Won't you just tell me why? Well, I'm here to tell you that if you identify with that perspective, the reason I didn't tell you why is because I didn't know why. I only knew what to do, and I could help you figure out what to do when, but I didn't really know why and all the behind. Well, now I do, and I'd love to be able to share that perspective with you. Let me illuminate this group a little bit more. This is my daughter's text to me from an Algebra 2 class where she says, wait, this is me right now. Wait, that rule doesn't make any sense. Teacher and other students, well, that's just the way the rules are. That's how it works. Me, but that doesn't make any sense. Why is it that way? That's just how it is. Grr. They expect us to memorize all these rules. Mesmerize is what autocorrect changed it to. Mesmerize all these rules instead of understanding and reasoning through it. To which I said, goodness, what's the topic today? If you're in an Algebra 2 class, what's the one thing you're going to teach procedurally over everything else? How about logs? Oh, there it is, logs. Can you see it on the bottom there? Then she sends me this picture of the division-subtraction connection with logarithms, and she goes, why do you subtract? Divide makes no sense. Logs are stupid. To which I reply, you make me smile. Let's talk all things logs when I get home. Or when you get home or when we're standing in line at the DPS, because she was literally getting her license that day. So this is my daughter in Algebra 2 who knows math is figure-outable because she has a mom that's what I've been preaching for a few years. Who knows that when I get home that night, and we talked all things logarithms. And what we did is we connected them to the exponent relationships that we developed the week before. And she goes, oh, logs are figure-outable. My daughter can absolutely mathematize with the best of them when she can think and reason and figure out and know the behind, when she knows why. I would ask you to think about these three perspectives. Do you identify with any of the three of them? What I really want you to say to yourself is, just because it worked for you doesn't necessarily mean it will work for all of us in the community. But I have a suggestion of what will. If we will teach real math using technology and the power of visualization to emphasize that it's about relationships and connections to solve problems, then we tell the why to everybody. Now, it's not about ethnicity. It's not about gender. I put friends of mine and people that I know in all different categories. I want to make sure that you know that it's all of us. It depends really on how we first impacted mathematics. Well, I'd like to invite you to consider that first impact that it had on you and maybe make a choice about how you're going to think about mathematics and then teach mathematics based on the perspective that you have maybe now and not the one that you had in the past. So that's me and that's my daughter. Hey, you guys have been fabulous. Join me on Wednesday nights at #MathStratChat on either Facebook or Twitter, where I literally throw out a problem and then we mathematize. People from across the world send in their strategies. That would be a way for you to begin to maybe not be that Z perspective, that rote memorized perspective, or if you're that X perspective and you think, well, I can just teach this procedurally, and they'll see behind it, oh, actually, you'll get a sense of putting your brain on paper. Show me what you're thinking so the rest of us can join in with you as you mathematize. And if you're in that Y group, God bless you that you made it. Keep asking why and force the rest of us to answer the why. You guys have been fabulous. Mathisfigureoutable.com. You get my slides and some other things about real math. Thank you very much.
All right. Wow, that was good.
There's
Enjoyed it again.
So much time pressure on that, Kevin. I'm feeling it right now. I'm feeling how much time pressure. Sorry.
Okay, well, that's good. Yeah, I mean, now there's a note there, by the way. Yeah, I hope people know it. 7 for 7 is what we called it, but Pam takes it as more like 7 and a little bit. But in terms of a title, 7 for 7 sounds better. But that was good. I remember thinking that during that time, how we gave you that control, and it was like, I don't know, the light went off on you because you realized it's all yours. That's great. You could go back and forth, and that was awesome. I really enjoyed that. And if people do have questions, we'll watch the chat. You can submit them through YouTube, and we'll try and get to those. I have a couple of questions that I know I want to be able to ask Pam. And I think you did talk a little bit about sort of the different perspectives, and I think that was great. And you sort of said this is not an equity talk or anything like that, but you are as a female mathematician. I think it is valuable, and here you talk. I mean, me, the guy, the mathematician, male, is sort of the typical as people might see. Well, what were the challenges that you faced as a female in learning mathematics, and how what helped you in your growth?
Well, I appreciate that. And when I said it wasn't a traditional equity talk, it's just because I didn't kind of want people, as they look at sort of hidden figures, to think, oh, we're going to, sort of be talking about racial equity, even though I think we are, as we talk about those three perspectives, because if we don't teach real math, I think we unbalancingly hit on minority students. We were not supporting them well enough. So it's interesting. I knew you were going to ask this question. We talked about it a little bit before, and I've been thinking a little bit about my answer. I'll tell you briefly. I think that there were some times where it impacted the fact that I was female and some things that I had to do. But I also have some male colleagues that were very equity minded, that were actually very helpful in my career. So first I'll be a little negative, and then I'll go real positive. My second teaching gig was at a small rural school in Michigan, and it was me and 8 men. That was the math department. I learned a lot about cars and football, and they were a great group of guys. They honestly, I liked and respected all of them, and we had a good time. In that group of teachers, we did have some equity things going on, but it was much less about traditional sort of roles about equity. And to me, it was much more about their belief that some people had a math gene and some people didn't. So we were in a math hall. All the math teachers were in the same hall. And I had colleagues, again, liked and respected them, but who literally said, if kids don't want to be in this hall, let's just not even have them come down this hall. They would say, don't even have them in this hall. Let's give them a test. This was slightly before all the high stakes tests took over in the United States. And so there weren't a lot of high stakes tests at the high school level at this point. And they said, let's just give them a quick test. And if they can pass it, they don't even have to come down this hall. And I said, I don't think I want to let freshman high school kids make that choice. I think freshman high school kids need to take mathematics. I think it's such a gatekeeper. And I don't know that they have the maturity at that age to make decisions for their future. And I think they should be taking mathematics. Now, I really wish they were taking a real math class, not sort of the rote memory and the procedural kind of stuff that we see too often. But I really want to give kids a successful experience, because then it opens the doors for what they actually want to do. We all know people whose careers were stunted, who they didn't actually do what they wanted to do because they couldn't do the math. I don't want that to be a barrier. So let's talk equity. I want to open and get rid of all the barriers for anyone who's interested to do anything that requires math. And I think living could be a whole different way of living if we view the world through a real math lens, through that sort of lens about what it really is, not this kind of fake school math that so many of us were in. So that was my little negative. Again, I really like those guys. I'm looking at the clock. I wonder if I have time for a quick story. I'll tell you the positive. Actually, the first school, so that was the second school I was at, but I got a really, really good start. A gentleman hired me for my first career, and he absolutely treated me as an equal and absolutely was very supportive in my career, and was sort of the opposite. He had a very expansive view of who belonged in mathematics. At that time in both of our careers, it was very unusual for schools to have large calculus programs. And he was the calculus teacher, he was the math department chair at the school. And he had an extremely large calculus program because he also taught the pre-cal. And so he just got everybody to take calculus, and it was cool in that school to be a calculus student. And I know it's always, like somewhat cool, but it was like cool. It was like the thing, like the popular kids did what they could do to actually make it in there because of what he did. All kids could be successful in his department. So I had also this other perspective of what it could really be for us to open up math to all students and support all students and in their mathematical development.
Oh, that's great. And I think you're right in terms of looking at it. And it's funny, the department I started with as well. You're right, was a pretty balanced department, and that really helped a lot. That it was that there were a number of, and I still remember that one of my first mentors as a teacher was there was a female member of the department. She sort of guided me through a lot of things in my first year of teaching, and I certainly owe a lot to her, and for that work, and sort of giving the example of that, because it can get can get skewed. I know even at university there was a lot more males than there were females in the math programs at that time. So
Hey, Kevin, let me say one thing that they did really
sure.
well. That school, one thing they did really well that I think all schools could learn from, when they set up the schedule for the next school year, that we'd gotten the enrollment, we know what kids had signed up for, how many kids were going to be in each class. we then, as a department, now again, it was a small department and we could do it. I think you could make it work at bigger places, but literally with seniority, the most senior person would choose the class or classes that they wanted, but only one. So the senior guy chose calculus. The next guy got pre-cal. The next guy got geometry. The next guy got or algebra 2 and then geometry, whatever. And so as a brand new teacher, I ended up with an algebra 1 class that first time, or maybe a consumer math, I think at that time. But then we went back around. And as we went back around, that senior guy had to take what we all considered one of the not fun classes to teach. And so what ended up, and then we all took a not fun class. And then we went back around and everybody got a class they wanted and then a not fun class. What it meant was the calculus teacher was teaching algebra 1 and the pre-cal teacher was teaching geometry. And we had more of a vertical look at we were a better and stronger department because we were kind of forced to work together. But it was our choice. It was our choice as a department to do that. And my hat is off. I think the more that we could do that kind of collegial working together at the higher levels of math and the lower levels, that we would have a much stronger program at all of our schools.
Oh, that's excellent. Yeah, it's funny, guys. That's very much like we had done it as well when I was department chair. As you're right, we had up where I'm in Canada, you have sort of, we had maybe more we called it an advanced level, the real mathy students, and then there was the weaker students, and you had to make sure that everybody had one class that was in with the advanced kids and one class that was with the general kids and one class with the senior, the 11 and 12, and one class with the 9 and 10. And you're right, it gave a so much better perspective when you had department meetings and chairing and trying to understand the whole program because you had a better feel. Excellent.
Absolutely. Yeah.
Yeah. We're talking about this has been great. One thing I don't want to admit that the part with students, and I loved your movie reference. Stand and Deliver was one of my favorite movies. I always loved that. The whole story of Jaime Escalante. And one of the things that always struck me with that movie, I don't know if you remember it or not, but he kept talking about ganas. The need for, I hope I'm pronouncing it correctly with my Spanish, but this idea of desire. He said you have to have desire. So what are your thoughts in terms of helping teachers? As you said, this idea, and your one daughter with this asking why, but how do we create that desire within students and that desire to ask why instead of just saying, just tell me how to do it?
Yeah, and so this goes back a little bit to kind of what I touched on. It was so quick in the 7 minutes, but there's this idea that there's this fake non-connected school math and there's actual real math, what mathematicians do. And if it's about doing real math, if I could encourage teachers, if you don't know what I mean when I say that, I'll give you some resources in a minute where you can learn more about it. But the more real math we do, the more we expect students to do what mathematicians do. Now, not at the level of a research mathematician, but at a 9th grade level. Like kids can mathematize at their grade level. They can actually, what do mathematicians do? Mathematicians solve problems using relationships and connections they own. And in the process, they create new math. Well, I think students can do that. Now, maybe not create new math for the world's never seen, though it could be, but they create new math for themselves, that as they wrestle with relationships. So I think that as a mathematics teaching community, we have taken the easy road, the shortcut to say, this is the math that's been developed. And instead of helping students develop it, we just sort of give them the rule. And we're all about answer getting. Phil Darrow talks about how we have to help kids learn the mathematics, not just get answers to problems. And I think he has a really important point. And the reason I bring all that up is if we want our students to really get into and be excited about and have an interest in mathematics, then it has to be the real thing. That's what's interesting. Fake math isn't interesting. I don't blame anybody for not being interested in fake math, but real math is intriguing. The way that we can sort of mathematize our world is interesting. I think we can use the natural nature of the subject itself. If we actually do real math, then kids will be naturally intrigued.
That's cool. That's great. Just watching our time, just looking for what we've got, because I do know, I think we'd be amiss to not. You've done so much work with this idea of math as figure outable. With that, what's one of the sort of the things in working with teachers? I mean, you do that is one of the things that you spend a lot of your time is working with teachers and helping them to help students with this idea that math is figure outable. What are some resources? What are some of the parts of the program you could share with us tonight?
You bet. So if you're interested to follow my work and learn more about how math is figure outable, let me share. I'm going to share my screen, and I'll just share a couple of resources with you. So this is mathisfigureoutable.com. I think math is figure outable and teaching math is too. If you go there and are interested to learn more, there'll be a pop-up that'll show up. You can join my email list. That's a way for you to, I think my emails are actually pretty helpful and informative. And so you can learn some things there. You can join me on Wednesday nights at hashtag Math Strat Chat I mentioned that in the 7 for 7, Twitter, Instagram, and Facebook. We've got all the places where I literally just throw out a math question. It's a number talk for the world. These are two different ones. Every Wednesday night, I throw out a math question, and then people from all around the world throw in their real math solutions. And you can actually see what it's like. Like, what do people do? What do mathematicians do to solve problems? Lots of people are learning alternative strategies by joining us on Math Strat Chat. Also, these are my Building Powerful Numeracy books. If that interests you, I also have a free online course. It's totally free, no obligation. You just join in and take the free online course. It's called Developing Mathematical Reasoning, where we really talk about what it means to teach real math and not fake math. I also have some online courses if you're interested. I have a thing called Journey. We also have some problem string videos that are totally free on my website, where literally you just go and watch real teachers in real classrooms with real kids pull that reasoning out of kids, because I think that's one of the hardest things to do, is to kind of envision what it means to be able to teach real math with students. And we mentioned earlier the Math is Figure Outable podcast. We kept them pretty short because we know teachers have sort of short periods of time. So they're about 12 to 20 minutes long, where we, again, talk about how math can be really figure outable. So math is figure outable, and I believe that teaching math is too. So if you're interested, that would be a great place for you to go to sort of learn more about how math can be more figure outable.
Awesome. I know I enjoy podcasts are for teachers, and I think we really appreciate for teachers. This is a very stressful time, but I know I've talked to some other T cubed instructors as well, that the idea of just sometimes putting on a podcast in your car on your way to work in the morning, it's great. And I've also tried to pick up that habit a little bit at night, just saying, okay, I want to sort of wind down. I don't want to be watching TV. I'm on a screen most of the day, so it's
Right.
kind of nice. And I thank you for adding that. I think that would be another excellent podcast for people. As you say, you just get a chance to listen and pick up a few things that hopefully energize you and get you going. So that's awesome. As far as the things, we've got I guess about a minute or so left. I don't know if we'll be able to squeeze something in here. I'll give it a try. But in terms of students themselves, so like just getting your daughter, you said, came up and naturally asked why. For students that are hesitant, is there any sort of quick strategy thought that you can sort of get them to want to
I
ask?
actually, podcast episode 15, I think. I totally talk about how
Okay.
how what you want to do is you kind of want to
Awesome.
have some questions with a bang. You want to have something like I gave the problem 99 plus 47 and 99 100. That's just 100 plus what's left over, 46. Give them a way of going, wait, that's a thing? Like, you can actually use relation. You don't have to line them up every time. So then I like to ask things like 99 times 47. Can you think about 147s and then just get rid of a 47? So those are my favorite two. When someone says, well, give me an example of real math and not fake math. Those are my favorite two quick examples about how lots of people actually do that naturally, but not everybody. I didn't, but I can now. And we all can do more real math.
Awesome. That's good. Yeah, just getting you're right. I mean, I could see asking students, just getting them to think, why is that the case? Those are great examples. Well, I want to say our time, while went really fast. Thank you so much for joining us. For those who aren't familiar, again, the 7 for 7 is part of the annual conference that we have, our international conference. This coming February, there's another one. It's virtual this time. Unfortunately, we're living in a very virtual world at the moment, but there will be 7 for 7 presented there. I encourage you, if you're interested, education.ti.com. You can register for the conference, and part of that is attending the 7 for 7 session. And there'll be instructors, T-Cube instructors, just like Pam, excellent in their field, and they're sharing what they're passionate about. So thank you, Pam, for sharing your passion this evening. Looking forward to hearing more from you. Thank you. Take care, everyone. Good night.